Hey everybody, thanks so much for coming to our talk. I'm Jeremy.
And I'm Jonathan, and we work on machine learning tools and libraries for recommendation systems at Netflix.
We're going to talk to you today about PolyNotes. So PolyNote is a polyglot notebook environment, which we built from scratch. And how many people here have used a notebook tool of some kind? Okay, so a lot of people, good. For anybody who hasn't used a notebook tool before, a notebook's basically a document containing code and the results of executing that code, and typically some text describing what the code is doing. And it's useful for data science exploration and experimentation, among other things. Some notable examples you may have heard of or used are Jupyter, Zeppelin, or Mathematica. So given that those tools exist already, why did we build PolyNote? And the reason is we noticed our scientists were, or some of our scientists were avoiding Scala notebooks for their experimentation needs, and instead they would either prefer Python-based notebooks or they would just abandon notebooks altogether, which is a shame because it has a lot to offer in terms of productivity and iterating on experiments. And it's a problem when they choose Python because our infrastructure is largely based on Java and Scala, and it's much easier to productize a notebook when it's already written in the same language. It's using our platform and our libraries already. And if you port from Python to Scala, that's a good opportunity to introduce bugs or other subtle differences that may affect the outcome of an experiment. And the reason they were doing that is just a pain to use Scala and Spark in a notebook. And some of the specific pain points were just the editing experience in general, I think. So interactive autocomplete is practically a necessity when you're editing Scala. And that's just because it really helps you find APIs, imports, and discover type signatures of things. And so that's really missed in a notebook tool, which typically doesn't have that feature. It's difficult to find compiler errors because Scala is a compiled language. People are used to having in their editor a little red squiggly when something doesn't compile, and a lot of notebook tools don't give you something like that. The dependencies in a Scala project are much greater number and more varied than typically in a Python environment. So a lot of our researchers, for example, may have dozens of transitive dependencies that they need for their experiment. And those dependencies can often clash with Spark's own dependencies, which leads to researchers spending a lot of time building shaded jars, and that's time that they could be spending innovating on the algorithms instead. So just some context here to show you that we really tried not to reinvent the wheel with this. So the original idea that we had was just an IntelliJ plugin that would run notebooks for Scala and IntelliJ while leveraging IntelliJ's built-in editing capabilities. And we made various attempts at that over the years, and they didn't really pan out that well for us, and we'll talk about why in a little bit. And I found myself grumbling about these issues over time. And at some point I thought, if you think you have all the answers, why don't you try to implement some of this stuff and see maybe it's harder than you think. So I started this proof of concept as a side project sometime in August of last year. And I started sharing, by October I had a working proof of concept, and I started sharing it with some researchers. And I got some positive feedback, and they said show it to other people, so I did that. And pretty soon I actually had a couple of people using this tool. And around the same time, Jonathan was also working on the Scala notebook problem from a different angle. So he was working more on evaluating if we could make an impact on the Jupyter side. And I heard that he was doing that, so I showed PolyNote to him.
And it was immediately clear to me, having tried these other approaches, that PolyNote was the way to go.
So by the start of 2019, we actually had people using this for real work. And at that point, Faisal, shout out to Faisal, took a gamble on it and decided Netflix would start investing in this product to see where we could take it. And Jonathan came aboard to work on it and really started to take shape after that. And then 10 months later, we announced it as open source. So we wanted to talk about some of the things we learned first in this process, and then Jonathan's going to show you some demos of it. So first of all, I mentioned that we tried to make this an IDE plugin, and it didn't really pan out. So what went wrong? Why couldn't we do this as like an IntelliJ plugin or an Eclipse plugin or something like that? And the reason really is that a notebook has to display a lot of rich, sort of heterogeneous document-like content. Things like rich text graphics, plots, LaTeX equations, data tables, and even some dynamic scripted interactive content. And the only standardized, really pre-baked mechanism for that is HTML. And that means you can either support HTML in your notebooks or restrict the richness of what it can display. And that leads to you can really either embed HTML into your UI, or you can embed your UI into HTML. And for us, it turned out to be easier to do the latter, because there's not really a feature-complete HTML implementation on the JVM, at least not one that can compete with what Firefox and Chrome can do. And interestingly, a lot of other IDEs are also now getting embedded into HTML. So maybe that's a trend there. But those tools aren't widely used on our team, so we decided to just try this out with a standalone web app. And interestingly, JetBrains now has their own IntelliJ-based product for doing notebooks, which I've heard about. So somehow they've succeeded there where we failed a couple of times. But I haven't seen it yet, but it'll be interesting to see how they've done that. So definitely check that out. And why not do a Jupyter kernel? So this was the other approach that we explored. Because after all, Jupyter is heavily used and invested in. There's lots of people at Netflix that contribute to Jupyter, and a lot of people at Netflix that use Jupyter, and we continue to invest in that ecosystem with things like Interact and Papermill, and we would never be our goal to displace that. So why not just work on a Jupyter kernel instead to integrate with our other investments there? And we considered maybe contributing to Almond or trying to adopt that and see if we could use that to solve some of our problems. And that Almond actually, since then, has come a long way, and it's really stable and it works really well. No thanks to us, unfortunately, but if Jupyter works for you, you should definitely check out Almond. But while we were investigating that, we came to the conclusion that the kernel was really only part of the problem for our use case. So a lot of the features that we wanted to implement and that were important to us, it's possible they could have been implemented as a Jupyter extension, but Jupyter's model isn't really equipped to efficiently support some of these features that we wanted. And the reason is the document state in Jupyter is all client-side. So any edits you've made to your notebook exist only in your browser until you hit save. And that's limiting and causes some various issues with the experience. For example, if you want to autocomplete, you have to send the entire content of the cell to the server, and that's not something you'd probably want to do on every keystroke, because those extra couple hundred milliseconds of latency get really noticeable when you're doing interactive autocomplete. And there's other issues with the model, like what happens if you start running a 10-hour notebook and then you close your laptop and go home. It's not super straightforward how to deal with that in Jupyter. And like I said, some of these things can be handled with extensions, but what we really wanted to do was to build it with a model that the document lives on the server and only edits are sent from the client to the server. And it turns out when you use a model like that, you get some other cool things like collaborative editing more or less for free. So I'm going to hand it over to Jonathan now, and he's going to talk about what makes PolyNote different from other solutions.
All right. Thanks, Jeremy. I'll attempt to show some videos on here, so cross your fingers for me. And so let me just get my mouse over there. So I'll be discussing some of the features of PolyNote to really showcase what we have to offer. And we'll dive right into the editing improvements. So Jeremy already kind of talked about these quality of life, IDE like autocomplete, parameter hints, and squiggly lines, very important. Here's a little video here, pre-recorded. That should start. Yeah, so I'll start, my past self will start typing some code, and I can barely see, oh, I'll see it, okay. And so we're just gonna mess about with a concurrent hash map. And the particular example is not really important, but we just show the autocomplete parameter hinting. And as I type here, I can talk about this little code editor, which is based on Monaco, which is open sourced by Microsoft, and it's the engine, and it running behind VS Code as well. So it's awesome that they open source this so that we can just drop it right into our app. And so let's run that cell. Okay, great, so we've got our little value there. And the next thing I'll show is just, we'll generate a syntax error and show us a little squiggly line. Okay, there we go. And so we show both, okay, you can see it, both the squiggly line there that's out of my view and also the error. And we see that on the error, there's also line 5 there. So you can imagine in a very big cell how this could come in handy. Oftentimes we see our researchers with a single cell that can span the entire web page. And so hunting for errors in that is really problematic if you don't have the nice little squiggle. And now I'll show this rich text editor that we have up there. Has some improvements as well, like just the simple toolbar where you can bold and underline, and hope everyone can see that. And also you can type in LaTeX, but I didn't do that here. So hopefully you guys got a little glimpse of what it's like to code with PolyNote. And next I'll talk about how we tackle the notebook reproducibility problem. So earlier when Jeremy asked, a few of you raised your hands. How many of you have tried to use a colleague's notebook only to find that it didn't run on your machine? Okay, that happens all the time for us as well. Basically, the cells got executed out of order, something got deleted or modified, and then the state you see when looking at the notebook on their machine doesn't work out if you just try to run it from the top. And the reason for this is essentially that there's a disconnect in the notebook model. Notebooks give you this UI where you see a whole bunch of states at once. So all these executions that happened at various times, you get to see them all at the same time. But the REPL that's actually interpreting the code only sees the code one at a time. So just every time you press execute, we send everything to the REPL, it executes. It doesn't know anything about where the cell, what cell it is, what's going on in the notebook, and all that. And then the problem there is we've got all this hidden state that you need to keep track of. And the way PolyNote solves this is simply by not being REPL-based. And so we'll talk about what the implications of that are. So here's a simple example, very trivial notebook. We've got foo, we're sending it to 1, we're gonna print it out, and then we're gonna set it to 2. And yeah, okay, let's try and see what happens. So we're just going to run through this. Okay, so as we saw, we ran cell 1, printed foo as we expected, printed out 1, then we redefined foo to be 2. Now anyone who's used Jupyter before, what are we going to print out here? Okay, let's see what happens. All right, it was 1 again, not 2. But maybe like it didn't take. Let's see, maybe the execution didn't work or something. Let's find out. Got a little impatient. No. All right, it's still 1. So what's going on here? Essentially, in PolyNote, a cell's ordering inside the notebook actually has a semantic meaning. And essentially, a cell can only receive inputs from the cells above it, and anything that happens in the cells below it can't affect it. So in this case, this cell 2 here can only see what happened in cell 1. Cell 1, of course, has foo equal to 1. So we don't really care about what happens in cell 3 and so on. Now, doesn't mean that this is immutable, of course. You can always edit cell 1 and then see something else, or we can insert a cell above. Okay, and as you would expect, we redefine foo because it's above the definition kind of takes, and then we print out. So I'll take questions at the end. Sorry about that. Okay, so that's about all we have to show. Oh, and then we do keep track of the state as things happen. So if we delete this new cell we made, and then print again, we're back to 1. So hopefully you can see that these changes help improve the reproducibility of notebooks, because essentially as the users iterate on their PolyNote notebooks, it's always making sure that they can run again from the top. So now we'll talk about visibility. Visibility, by which we're referring to basically giving the user a better understanding of what's going on behind the scenes of the notebook. So we have a few kind of UX features that let you kind of feel like you have more control over what's going on, more information that can help you as you're editing. So this is a bunch of code right now. The actual contents aren't that important, but I'll run it through and we'll see what kind of information PolyNote gives when you execute. And you might have noticed this in the previous demos. Okay. Now I was supposed to go back to the beginning here.
Play through and then click it.
Yeah, I'll just let it play through and then. Okay, so now we're going to run through again, and I'll pause and do some explanations. Okay, so the first thing to notice is we press the execute all button, which of course many other notebook tools have, and we immediately see that cell 1 is running, and cells 2 through 4 there are queued over on the right-hand side. And we see the order in which they're queued, which is something that you don't see in some other tools. And we also there's a little highlight here which shows exactly what line is being executed, and it's also mirrored over here. And when I unpause, you'll be able to look at this highlight here and see as it moves through each expression as it gets interpreted, executed. Oops. Okay. So now we've got to a little Spark job that doesn't do anything of interest, but what we can see here is this little progress bar appeared underneath cell 1, which shows that we're in, the job ID, what's going on, and then what stage is running as well. And now I'll keep going for a little bit, and we'll see how, as the cells get executed in turn, their progress bar disappears. Okay. Now the next thing to show here is this symbol table. Right now, because no cell is selected, we only see the Spark session, which is what PolyNote provides for free when you start up a Spark notebook. But as we start selecting cells, we'll be able to see the state, the symbol table change, reflecting the state that's available to the cell that's being selected right now. Okay, so we selected cell 1 here, and we see that the symbol table has changed now. There's a dark line here, and we can see these two variables that are defined inside the cell above the line, and of course that old Spark variable below. And what this line delineates is the outputs above from the, the outputs above from the inputs below. And as we click on, for example, cell 2, we'll see that now the output is Y, because that's defined, but all the state available to it, the inputs, are below. Okay. Of course, so hopefully these UX improvements go a long way to help you understand what's going on behind the scenes. Now, of course, it's in the name PolyNote, so let's talk about Polyglot. Every cell in the notebook can be written in a different language, and variables and state can be shared between them. Currently, we support Scala, Python, and SQL cells, with SQL essentially being Spark SQL, so I'll focus today on just Scala and Python. And so here's a little example of a Polyglot notebook where we have this first cell here is written in Scala, and the second cell is a Python cell. And this is just doing a very simple thing where we do a bunch of, some data generation or preparation in Scala, and then do some plotting in Python. And this is one of the main use cases that we find value in this Polyglot support, because people just like matplotlib, but people also want to use our platform, which is written in Scala, to generate data. And aside from matplotlib, another thing people use Python for a lot is, of course, machine learning, like TensorFlow and things like that. So this lets them use the same libraries, the Scala libraries that we already have for data prep, but then bring TensorFlow, scikit-learn, whatever they want. So we'll just run these two cells now. And we'll highlight toArray there. We'll get back to that later. And then it ran. We have a nice plot. And then, okay, we have moused over data to highlight that. So that data variable here is the one defined up here from Scala. And the reason I bring up the toArray conversion here is just to show that this Python and Scala interop, it's not like super magic or anything. You have to do a little bit of playing around. And under the hood, we use a great library called JEP, which stands for Java Embedded Python, which runs an embedded C Python and Java through the JNI. And that's doing the heavy lifting of translating variables back and forth. And the reason it's better to use an array is because arrays are these data structures that everybody knows about. Whereas if you had to send like a Scala seq or a list over to Python, it's not really going to work in a nice way. So here, because it's an array in the JVM world, it just nicely slots into a list here in the Python world. And we think this is one of PolyNotes' most interesting and powerful features. And now I'll talk a little bit about the dependency and configuration management. Essentially, this nothing super amazing here, but just by saving the dependency info and configuration inside the notebook itself, rather than being kind of a function of the environment, as it often is, we're able to get a lot of leverage and just be able to operate these notebooks that lots of users are using and make them more portable so they can be shared. And so I'll just show a little bit of the UI. So we have this little UI here that allows you to put in packages like Maven coordinates or even S3 jar locations, things like that. If you do use coordinates, we'll use Corsair to download those dependencies and also their transitive dependencies for you. And you can define IV and Maven repositories here, and of course we can exclude Guava from our programs using this here. And this also works for the Python as well. So this you can make a pip dependency here, like matplotlib, say, and then here you can put your company's pip PyPy repo as well. And finally, we have an area here for the Spark configuration. And the nice part about, aside from having making this portable, is when you put the Spark configuration in the notebook itself, we can read it before we launch the notebook kernel, which lets you set the driver memory, which has been a problem for us at least when using other notebook solutions. So we don't have to ask users to edit shell scripts in order to change that. Finally, having all of this in the notebook file, which is essentially just a JSON file, allows us to interoperate with some of our other internal tools at Netflix. So one of the things that we can do is we can have a tool that just generates a notebook that a user can download, just hop into, and we preset like an environment, let's say a jar where something went wrong in production or something like that is already present and available. So that really helps us out as well. And finally, I'll show some of our built-in data visualization. So we have this data inspector here that I'll talk about. And what we can do is, so this cell here, we're just generating some pretty looking data. We're going to plot it down there. And then in the bottom, which we're actually going to go to first in this video, we'll show some interesting a collection with some kind of structured data. So we've got a bunch of pets. They're all dogs. And we can see just what the schema looks like immediately after we run this. And we can, and this is kind of, you can imagine it's pretty useful when you've got like a very complicated nested data structure that you have to deal with up there. Now let's talk about this graph. So again, it's just this little, this function that generates a bunch of data. And the key thing to note on this is just that we also add some noise, which I'll show later. And this schema isn't particularly interesting, but we have these little quick access buttons here that take you to both a tabular and a plot view. So we'll click on the plot now. And then, so we can have a plot, but let's first take a look at the data so we know how to plot it. We can just page through it, which will stream some data, page through the data basically. Okay, it's a bunch of numbers. That doesn't tell me much. Let's plot it. We'll do a line plot just like the one over there. And we can set a little quartile view on the y's, and then just drag over the x-axis, and we'll start plotting. And this takes a little bit of time just because we're actually running a Spark job right now behind the scenes to stream the data over to the client. So there's a little hint of that over there. Boom, we've got our data. Looks just like the one we just saw. Let's save it to the graph, to the notebook. And so now we've got this graph sitting in our notebook. And this graph, if you notice here, it's actually a Vega spec type cell. And what that actually means is we can show the Vega spec. and see that we just have the JSON right here with a little bit of our little secret sauce to actually pull the data out and aggregate it. But what this means is if you have some Vega JSON that you want to plot, you can just paste that in there, and then it'll plot for you. And now that's been a whirlwind tour of PolyNotes features. Over to Jeremy to talk about what we learned building it.
Thanks. So I work mainly on machine learning libraries. So for me, it had been a while since I'd done any sort of full stack web app development. And given that, people, including myself, were kind of surprised at how quickly the POC came together. And then it went from a POC to an actual useful tool that dozens of people voluntarily use for their day-to-day work in like less than 10 months of 2 people's part-time attention. And not to brag about it, but I'm pretty proud of the functionality that it has given the small investment of man hours we've put into it so far. I thought we'd talk a little bit about the process of building it and some things that we learned, mistakes and successes, in case that's generally useful to anybody. So the first thing is obviously standing on the shoulders of giants, and this is not new at all, but I just wanted to call out some of the amazing open source software that PolyNotes built on the back of. There's Monaco, like Jonathan mentioned, which is the same code editor used in VS Code, and Microsoft's actually open sourced that as a JavaScript component you could just drop into a web app. HTTP4S and FS2, these are 2 amazing libraries that are built on Cats and Cats Effect, and I was just blown away by how easy it was to just put together a server and a couple lines of code. It's got WebSocket support out of the box and a really reasonable model for working with the WebSockets. And it just works, you know, which contrasts with some of the heavily configuration-oriented JVM-based server frameworks that I was familiar with. And we didn't have a config file at all until a couple months after that. So that really blew me away. Zio we adopted a little bit later on, and we'll talk a little bit more about that, but that brought some really amazing innovation to how we could structure our code. Kudos to Zio team as well. Scodec let us just build an ADT, and then bam, for free, we have a compact binary protocol for those messages. And that's really one of the reasons I think that PolyNote feels so fast. Corsair, like Jonathan mentioned, for dealing with those dependencies. Anybody who's used Ivy would know how much of a nightmare that would be without Corsair, so shout out to them. Circe we're using for configuration files and to actually read and write the IPython notebooks, which is the notebook format that we're using. And Jonathan mentioned JEP, without which we probably could not have added Python support so easily. So a big shout out to all those projects. And you know, I was surprised almost and pleased with how rich and mature the open source ecosystem in Scala is now. It's really come a long way, I think, in the last few years. And I feel like these libraries almost gave us superpowers. You know, it was shocking, and I say shocking not to brag, but because I was actually kind of shocked myself about how quickly we were able to build new features and fix bugs, and our users were impressed by that too. I think that's one of the reasons that we sort of developed some diehard supporters of our tool. And I was really pleased with how welcoming the communities around these projects were as well. So we would always be jumping on Gitter with stupid questions, and there would always be somebody, some courteous community member there to help us out. So, you know, just a big shout out to all the people that work on Scala open source or contribute to it. It's making an impact, so you should know that. The next thing is that I/O with functional programming is really awesome. So I had used it in some libraries. I was no stranger to functional programming, but I hadn't had the opportunity to build an application from the ground up with something like Cats Effect. And I was a little bit skeptical about the trade-offs of doing that, but doing it, I was just blown away by the advantage that it provided. We had to cut some more slides, some more material about that, so feel free to talk to us about it in the hallway. With ZIO, we adopted, or I guess it's Zio, we adopted it about 7 months in, and the reason was mainly to get interruptible I/O for free. We have those tasks that are running. There's actually literally a button to cancel a task, and when somebody does that, we want to do the best we can to cancel it, even if that means interrupting a thread. And so ZIO gives you that out of the box, and we could get rid of the hacky stuff we had in place to do that with Cats Effect. But if we came for interruptible I/O, we stayed for the environment mechanism. I'm sure that'll be covered by other people in more depth. We had to cut some material about it, so again, feel free to ask us about it. So the last thing I want to talk about real quick is just what we learned from open sourcing this, because this was the first project that I had open sourced under sort of a well-known name, being the Netflix open source umbrella. So it's actually been open source since the beginning as a side project, but in October we made a blog post and sort of exited stealth mode on that. And it was a pretty small project from just like me and Jonathan are the people working on it. And we didn't expect to get much attention. So we felt kind of okay about maybe taking a little victory lap in our blog post and patting ourselves on the back a little bit. But we didn't consider how that blog post would look to people without the context that we had. Like, we know the scope of the project and we know it's like no big deal. But we didn't think about the fact that this is going to be a blog post saying, Netflix releases this thing. And it's going to give people the mental image of like Reed Hastings storming into the boardroom and saying, oh, we have to release PolyNote to open source. And obviously nothing like that happened, but we didn't really think about how that would appear. And in retrospect, we should have been a bit more transparent in our blog post. And it got a lot more attention than we expected. And it was mostly positive. The only negative stuff were people complaining about the logo. But it did get reblogged a lot with a bunch of sort of misleading headlines. So just for entertainment purposes, we're going to just go through a couple of those. So this one's fun. What you need to know about Netflix's Jupyter killer. So PolyNote is emphatically not a Jupyter killer. It's not intended to be a Jupyter killer. And Netflix is always going to be big into Jupyter. I promise you that. So, this headline was a little bit bothersome, actually, because a lot of our colleagues contribute to Jupyter and are active in that community. And yeah, so I can imagine some concerned emails. Here's another one to just more Jupyter confusion. Again, we're not really related to Jupyter. But this next one's my favorite, and then I promise I'll stop. Did Netflix just kill Databricks? Right? So obviously the one-word answer is no. And I think the article also probably came to that conclusion. But this kind of clickbait can really paint our intent in the wrong way. I guess the lesson is, hopefully our friends at Databricks got a good laugh out of this if they saw it. But the lesson is kind of, be more considerate about, how your post will be conceived or perceived by the people who don't have that context. So this would have been the real headline if there was one. But I hope we gave you an idea of what PolyNote actually is, and come check it out, PolyNote/PolyNote on GitHub. PRs are welcome. And again, we had to cut out a bunch of stuff, so feel free to talk to us about that in the hallway. And I don't think we have time for questions, but yeah.